So this error, I would say, is probably like the third or fourth most common error when we're dealing with data sets, right? But what I mean by that is if you look at the humidity column, right? The humidity column, we see the first couple of values are numbers, right? Nevertheless, the data type of that column is CHR. That stands for character. That basically means it's what we call alphanumeric string. Now, what is an alphanumeric string? Basically, anything that's a word, right? Think of it now, a word, a person's name, a street, a city, all those like letters, anything with letters and words, right? Those are considered strings. They're stored as what we call characters, right? But numbers, now look at these other these data types. We talked about this before. int is an integer. That's basically a number without a decimal place. And num is like an integer, except it allows for decimal places, meaning it takes up more memory. In terms of memory, integer is the most efficient. Then comes num. Then comes character. Character, obviously, because it's not just numbers, it's letters as well. It takes the most amount of memory. Now, a lot of times you'll come across these data sets where you have a column humidity. Now we know what humidity is, right? Humidity is like a measure of how much moisture is in the air, right? It's a number. Why is this column being stored as um, a character? This is usually because and when you see this in a column, you see numbers with quotes around it. That's because in that column, there's a word somewhere. Words or words, like some of the values are actual words, like Arizona or whatever, right? And that's causing, see, if one value in that column is a word, is a alphanumeric, then the whole column becomes character. Why? Because that column needs to allocate enough memory just for that one word. And because it has to allocate all that memory just for that one word, the whole column gets allocated that memory. My BAP students, this is similar to, again, to how NumPy arrays work, that each value, they designate the memory type of that NumPy array based on the value that needs the most amount of memory. And if just one value needs a lot more memory than all the other values, it doesn't matter. Everybody gets allocated that memory. Everybody gets allocated that memory, right? So that's basically what's happening. Humidity is being forced to be a character column type because of the fact that somewhere in that column, there's a character. There's some sort of alphanumeric in that value, right? Which most likely probably does not make sense, right? Humidity should be numbers. And again, look, if we're dealing with another table, right, and there's some sort of column, we have no idea what it is, but we see numbers under in quotes, we would also be suspicious of, hey, does this make sense? Is this right? Look, it could be right. It could be right, but we would have to verify it. We have to verify it. Now, in this case now, we want to investigate why is this the case. Enter a very powerful command called grep. Grep is a what we call regular expressions, a function that checks for regular expressions. This is actually built into a lot of other languages as outside third-party packages. Like, I think Java does have them, but you have to import a third-party package to do this. I think some companies have built them for C++. This is actually essentially from the world of Perl. Perl script used to be awesome at that, and both R and Python obviously co-opted this. For my BAP students, again, if you guys remember in Pandas, the str package, the string package, right? The string package. Within the string package, there is a grep command. So you have the grep command available to you in Pandas as well, right? But this is how we use it in R, right? It's just a simple native function. Now, regular expressions essentially are a way to find certain patterns in strings or alphanumerics, right? In our case, we want to basically check to see if any of the values in the humidity column is a letter. That's what we want to see. We want to see if any of the values in the humidity column have a letter in it, right? It could be a whole word or just one letter. I don't care. I want to check for it, right? And the way essentially it works is, if I give you guys the command of how the syntax here. So grep has its own syntax, right? It's all its own thing. The way grep works is, firstly, It's a function. Let's understand that, right? It's a function. Now, notice that this function, right, it's called grep. Here's the opening parenthesis. Here's the closing parenthesis. And there's a comma inside it, meaning that it takes two parameters. The two parameters it takes is the first, well, let's talk about the second parameter. The second parameter is easy. The second parameter is basically the column that you are searching for some sort of string pattern in, right? You're looking for some sort of string pattern in this particular column. All right, the first parameter now is basically you're defining what pattern you're looking for. And this is how the grep, I'm actually going to post for you guys a cheat sheet on the grep syntax, right? It's very powerful. I mean, I could spend like probably 1/2 to 2/3 of a whole semester teaching all the crazy things you can do in grep, right? There's a lot there. Very powerful, very convenient in a corporate setting, in work. All right, so this is in quotes. Firstly, the pattern you define, you have to put it in quotes. That's number one, right? And this particular pattern, what we're saying is, hey, you know, I have an open square bracket and a closed square bracket, and I'm basically saying, look, within the square brackets, I'm defining what I want to search in the humidity column. All right. Now, if I just put in hypothetically A, like let me show you here. All right. If I just did, fix the quotes. All right. Now, if I just had the quotes over here, right, if I just put the letter A, any idea what I'm looking for here, guys? In this situation, I'm looking for any value in humidity that has the value A in it, that has the value A in it. In fact, if you guys remember our DT column, our DT table, here's our DT table, right? So let's do this on the DT table. A, and we'll do it on column C1. All right, on C1. Notice which row I got back. All right, I got the first row back because in the first row I do have the value A, right? Oh, sorry. Now if we put this in we should wrap this, technically we should wrap it in brackets, right? And it gives us the same results. Now, outside of the brackets is basically saying, hey, just look for that one particular letter or one particular word, right? When I bring the square brackets in, I'm doing something more fancy, all right? Now, again, notice where do I have the grep function being called in line 27, 28? Which region do I have it being called, guys? I have it being called in that's right, I have it being called in the row section. I'm using the grep command to basically filter the rows of data, right? That is why in line 28, I got the first row back. Because in the first row, because if in the C1 column, only the first row had the A value. So it gave me back that whole row, right? So I'm basically using the grep command to filter the whole table by rows. All right? Now, back to the square thing. Same thing. Gives me the same thing as if I didn't use the square bracket. But what allows me to have these square brackets, it allows me to say, okay, you know what? Why don't we search for, let me look for DT. We can give a range of values, all right? So let's say I did A to B, dash B. Now what does A dash B mean, guys? It literally means search for values from A to B, inclusively. So A and B are included. I get the first rows back, right? You know what, let's do it on C3. Let's do it on the column C3. Because C3 is a little more interesting. It has A, C, and D. It doesn't have a B, right? So if I do it on C3, notice I only get the first row back because there is an A value, but there isn't a B value. Now watch when I do A dash C. It gives me the A value and the C value. A dash D, it gives me all the rows for C3. Why? It's giving me everything from A to D, including B, C, and D. Alpha, it understands the alphabet. It understands that, hey, I'm going from A to D and everything included, right? But that's lowercase, right? This is specifically looking for it's case sensitive, just the lowercase letters. So if I add an additional, I do space, and within the square brackets, I say also search for the capital A's to the capital Z's. And down here, let me do lowercase a to lowercase z. Right? So what's happening here is now it's saying, okay, look at this column. Firstly, we're filtering the rows, and we're filtering the rows by the C3 column. And within the C3 column, I'm basically looking for any letters, A through Z, A including Z, basically all the lowercase alphabets, and all the uppercase alphabets. If any of these letters exist in that column, grab that column. And that's basically what's happening here, guys. That's basically what we're trying to do here in our slide right here. Here we have the humidity column, okay? And in the humidity column, I'm saying, you know what? Check for any of the lowercase letters, all of them, A to Z, and check for any of the uppercase letter, A to Z. And I run this, and look what I get. I get this row. Again, don't forget, guys, that you're seeing, you see one over here, you see one over here, you see one over here. I just don't have enough space for my columns to go all the way across, so it just breaks up the columns. So the first couple of columns it shows here, then the next couple of columns it shows down here, and the last column it shows here. This is why they give you these numbers associated with it, just so you know which row it's from. So I just get one row back. So in the humidity column, we see here, there is a value x61. So you know what this means? It means that was probably supposed to be 61, and somehow an x got in there. Somebody typed in an x, and the whole thing became a character. The whole thing became a character column, right? So through identifying that, we identify any potential mistakes in the data. Oh, and by the way, this happens all the freaking time. Anytime you have human beings working with these Excel sheets, this happens, whether they're inputting it to a database or outputting. I was at one hedge fund, right? And forget their database. Like I was getting results back from the database, and their results and their values were incorrect, right? So I remember I was working on a project with their certain derivatives. Like we wanted to basically get a snapshot of all their derivatives and their positions, interest only, options, VAT, variable rate swaps, swaptions, all that stuff, right? But we couldn't even get to that. Like the first hour or two, I was like, no, I can't even get to that because I'm like, you guys have mistakes in your data. And they're like, what are you talking about? And I showed it to them, and they're like, oh, snap, right? And I showed exactly how many there were. And I used tricks like this pretty much. I was doing it in pandas. But regardless, boom. In this case, it's just one. It's wrong. And especially if you have people, like if data, a lot of times data from Excel sheet gets loaded into databases, and then later on analysts pull that data from databases and use it for analysis. If it's coming from Excel sheets, somebody's bound to mess up. It just happens. An erroneous keystroke here or there, right? And so boom, you have an X right there. So using the grep command, we identified in that column, hey, a value that should not be there. So we just want to make this into a, we want to get rid of the X pretty much, right? At this point, we just want to get rid of the X. And so at this point, right, I show you guys that, hey, all we really need to do is now, again, we're using data tables. We're now going to add comma, and we're going to call the humidity column in that row that we just selected. Look, line 29, we selected this row. Now I'm going to go one step further and select that column, right? Come in the column region. So I filtered the whole table according to that column, the value in that column. And now I'm going to select that particular column. So I just have that one value x61. And that one particular column, we just want to overwrite, right? I just want to overwrite that value. Now remember, in data tables, when you're creating a new column or overwriting an existing column, colon equals, colon equals. All right, so I'm sorry, here I have a typo. Here I do colon, actually it's not a typo. I have to do quote 61 right there, right? Because right now the whole table is characters, right? So I'll play along. I'll fix it. I'll do colon equals 61. All right, and now if I were to run this analysis back again, right? Again, just search for anything in humidity. Search for all the rows, all the rows, all the columns, where in the humidity column there is a letter, be it lowercase or uppercase, right? And now you'll see the result came back empty data table, blah blah blah, 0, empty. The result came back empty. Why? Now the humidity column has no letters in it. Now the humidity column has no letters in it. Now, from this point of view, I mean, a lot of times when I do this in class, a lot of my students will be like, oh, okay, that's for a particular letter, right? But let's say you have a column that has all kinds of combinations of letters and numbers, and you want to get rid of all the letters, right? Because in this case, we explicitly just changed one, but let's say we have like hundreds of mistakes like this, right? Is there a way we can use a grep to um, um, fix all the basically either get rid of all the numbers or get rid of all the letters from the column? Yes, there is. I'll show you guys that. I have an additional slide. It's just 2-3 pages. I call it Lab 2B, right? And I show you guys that as well because a lot of time my students ask me for work purposes how to do that. All right, so here we go. Again, I have to put it in quotes because the whole column is still a character, right? Now that we've cleaned it, let's go ahead and convert it now back into a number, right? In this case, I think we could use the integer because we don't have any decimal places. Humidities are just whole numbers anyway; they're not decimal places. And guys, here I'm basically showing you guys the different data types in R. So numeric, I already pointed out, integer, character. There's another one called factor. We will discuss this. This goes to that whole checkbox that make you guys check off every time we load up data. We will discuss this, very important. And dates, right? And dates, another kind of data type. And again, we'll talk about that as well. So when we're converting a whole column from one data type to another, there's a whole series of functions called as dot that are in R that allow you to change either one data type or a whole column from one data type to another. Here is an example, right? If I just type as dot, you'll see all these things pop up. As dot array, as dot character, as dot data frame, as dot data table, right? As dot date, as dot double, as dot factor, right? There's so much you can convert one data type into another, and it looks like you can also convert certain data containers into another, right? It's a whole world of as dot commands you have at your fingertips. We're just going to use a very simple one called as dot numeric, and it's really easy, guys. It's really easy how you do this. So in bike raw, I'm going to obviously, because I'm changing a whole column data type, I'm going to use the column section. But notice to the left, the row section, there's nothing there. Why? Because I want this to be for all the rows, obviously, because I want to change the data type of the whole column, right? And basically, we're just going to overwrite the existing humidity column with the as dot command humidity column. And this is going to go ahead and rewrite everything into this numeric data type, as dot numeric. So basically, it's going to take the characters that are in humidity, convert them into numeric values, and then store them back into the humidity column, effectively overwriting everything, all the values as numbers. I'm going to copy this. I ran it. And now, ladies and gentlemen, if I run the str command on bike raw again, you see clearly, very clearly, you guys can see, that down in humidity, look what I got. It became a numeric. Now we could have converted this to an integer as well. That's fine, right? I just used numeric. But you could, I think we do have an as dot. Let's see, do we have an as dot integer? Let me check. Yeah, so we have an as dot integer as well. All right. I just went ahead and used the numeric command and it converted into a numeric type. Okay. So now it's numbers, and no biggie if we do have integer numerics, it's fine. So at this point, we fixed this problem. All right. Yay. Excellent. All right, now let us talk about factors. Finally, we're going to talk about this. Now, from a theoretical point of view, data tends to be of two main types, guys: numerical and categorical. Right? You guys know this: numerical and categorical. In fact, you guys have all learned this before. You probably just never paid attention. All right. Numerical means numbers, things that are meant to be measured, things that you're supposed to apply equations to, mathematics on. That's what we mean by numerical. Categorical is everything else. Categorical can be further subdivided into what we call nominal data and ordinal data. Okay? Ordinal data, basically, right? And again, when we talk about categorical, it's anything or everything that's not a number. That's what categorical data is in the world of analysis. Categorical is further subdivided, as you guys can see here, between nominal and ordinal, right? Nominal and ordinal, if you follow my mouse. If the data, the categorical data, has some sort of order to it or some sort of magnitude to it, it's ordinal. Otherwise, it's nominal. What do I mean by if it has some sort of order or order of magnitude to it? For example, let's say you have a column that has the values first, second, third, fourth. Is that nominal or is that ordinal? That is ordinal because there's some clear order there with those words. First, second, third, fourth. Let's say I had a column that had values small, medium, large. Is that nominal or ordinal? That's ordinal because there's an order of magnitude there. Small, medium is bigger than small, large is bigger than medium. Okay? Let's say I had a column that had colors. Is it nominal or ordinal? Nominal. There is no essential ordering with colors. There is no order of magnitude with colors. All right? Ordinal is only something that there is, if you want, I mean, that's where the name comes from. There you can apply some sort of order to it. You can apply some sort of order to it. Okay? Now, in a categorical, for our analysis purposes, if the categorical data can only have a certain number of values, and only those values, okay, if you're looking at a column that can only have a certain set of values, right? Again, we're talking about alphanumerics here. Then the values in that categorical column will be considered factors. And we should make sure R understands that explicitly, right? We should make sure R understands that explicitly. Why? This is part of data analysis. When you have a categorical column, that categorical column should only be allowed to have certain values. That's the way it works. When we're dealing with alphanumerics, it can't be the Wild West. They can only have certain values. They should only have certain values. For example, when we're talking about, we're talking about stocks. All right, stocks could be of certain sizes. They could be a small cap, medium cap, large cap, blue chip, etc., etc. So there's certain terminologies we use to identify stocks that belong to a certain market share group size. All right. Also, another example I can give you is, if we're talking about like sports clothing, right? T-shirts. T-shirts can be small, extra small, small, medium, large, extra large, double XL, right? So if those are the only possible categories for the shirt size, that would be considered factors. This is an important concept because one, R needs to understand what the factors are when you're doing analysis on them, because you can only do analysis on factors. And I'm sorry, not only on factors, but you usually do analysis according to factors, right? And two, it makes your data, right? It's another like check on our data to make sure it's coherent. That only the values that can be there are there. There are no other errant values within our column, right? So that's essentially what factors are. And now, ladies and gentlemen, we can talk about factors and we can start talking about levels. All right, now here, let's take this example. In line 1, I have a vector called data. Very simple. It has the values 1, 2, 2, 3, 1, 2, 3, 3, 1, 2, 3, 3, 1. Now there's a function called factor. All right, the one there's a function called factor, right? If I call factor on the vector and set that equal to a new data container called fdata, fdata is going to look like this now. It's going to have the same values as data, but now it has this extra description that says levels 1, 2, 3. All right? There's data. If I type in data down here, you'll see it's a normal vector, right? Nothing fancy. But when I create fdata using the data vector and using the factor function, and now I type in fdata, I get the same result as before, but now there's something new called here levels. 1, 2, and 3. What does that mean? The factor, right? This is the factor vector, all right? And in it, it can only have 3 values. This is what the levels are specifying. It can only have 3 values, 1, 2, and 3. That's it. Now, if you try to put a different value in there, you'll get an error of some sort. It can only have the values 1, 2, and 3. All right, now we can take this a step further. By the way, notice I use numbers here instead of characters. So you can have columns that actually have numbers, but they're categorical data, right? They are categorical data. Our existing table has scenarios like this, and I'll point that out. I'll point that out. All right, so here, in this step right here, I create another one called our data, but now I'm using the factor function, but now I'm getting slightly fancy. I'm using a second parameter called labels to basically change the way the labeling is done, or the way the output, or the way the values are seen when we call them. All right. Here I do I2, 3. I'm gonna be slightly more. In my slides, I do 1, 2, and 3. I2 and 3. I'm gonna be more fancy. I'm gonna say, right? I'm gonna say apple, melon, banana. And yes, I say banana because I had a coworker from South Africa, and he would say banana, and I'd be like, yeah, that's the way I want to say banana. I think I'm misspelling it. Just go with it. So I type this in, and notice what happens. Now, because the original value here in data is numbers, what happens is automatically it says, okay, all the 1s will be displayed as apple, all the 2s will be displayed as melon, all the 3s will be displayed as banana. And now when I call our data, look what happened. You see, it's still being stored in R as 1, 2, and 3, these values, right? But when we displays them to us, it displays them as apple, melon, banana, apple, melon, banana. And the values, when I put them in there, I could put an apple, lemon, banana, apple, melon, banana, but it'll be stored as 1, 2, and 3, right? And here you can see the first value is apple, is 1. 1 is apple. Then we have 2 2s, the melon, and then we have the 3, banana. And it goes to the order right here we put it in. 1, 2, and 3, right? And that's why there's 3 levels, apple, melon, banana. When we are importing data, let's do it again. Real quick, let me show you. If I import, let's go to Documents, ABI. Right, let me just do the first one from before. If I click on Open, right? When I ask you to uncheck this, the reason I ask you to uncheck this is because if you don't uncheck this, what it's going to do is any column that has any kind of alphanumerics, it'll automatically it'll automatically convert those as factors. Automatically convert that as factors. And you might be asking yourself, okay, well, what's wrong with that? Well, we want to first always clean or manipulate those strings, right, before we make them into factors. We'll go ahead and we'll do that ourselves, right? We want that control, so that's why we prefer not to have R do it. We want to do it ourselves. Alrighty. Now, what happens when we load up the table and we check off strings as factors? What R does is basically looks at all the values in that particular column and says, okay, here are all the list of factors, right? And these are what the levels will be. Whatever the actual values are, those will be the levels. Right here, we explicitly choose what the levels will be. Right there, it does it automatically. Notice the command we use is called labels because we're basically labeling the levels. That's the logic they're using here. We're labeling the level. All right. And look, we can also go back and change the levels, right? So here I change the levels for F data, the existing F data 1, but I can go back and change the levels of our data to be the original 1, 2, and 3 that I wanted, right? So I come here and I go levels on our data, and here it will be I. Right. And now, if I type in our data again, you'll see it's the 1, 2, 2, and 3 from before. So wherever there's a 1, it's a 1. Wherever there's a 2, it's a 2. And wherever there's a 3, it's a 3. These are, again, what we're seeing. Okay? That's what levels and labels essentially become once we go down this path in R. And we need to go down this path in R. We need to identify our categorical data, and we need to identify the appropriate levels that data can take on. And you'll see a bit later why that's important. And so even if in the data underlying in the actual memory, you see there'll be 1, 2s, and 3s, and 1, 2s, and 3s, etc., etc. What we see is 1, 2, 2, 3, 1, 2, etc., etc. You get it? That's basically what it's all about. That's basically what it's all about. Right? So that's what levels are and how they tie into our categorical data. All right, now we have categorical data in our data sets. All right, let us see it. Here's Bike Row, guys. All right, in all its glory. Now, if you guys remember from last week or from the last video, season, holiday, working day, weather, right? These are numbers, but are these 4 numeric columns or are they categorical columns? Do you remember? Are they numerical or are they categorical? Let's say I don't have it here. Let me pull up the slides from Lab 1, right? Just to jog your memory. All right, so here, this is a great example of the fact that, look, you have numbers in the column value. Just because you see numbers does not necessarily mean that column is numeric, right? It does not see, it could be categorical data. And if you remember from Lab 1, this is our Lab 1 slide on page 13 from Lab 1. Season, these numbers mean something. Categorical. 1 means spring, 2 means summer, 3 means fall, 4 means winter. For holiday, 0, it's not a holiday. 1, it's a holiday, right? Whether the day's a holiday or not. A working day, whether the day's a working day or not, right? Right, all this stuff, these numbers, they mean something, whether it's a working day or not. Working day, working day, working day. Holiday, not a holiday, which season it is. The weathers, remember, the 1, 2, 3, and 4s, they mean something. They mean something categorical. 1 is clear, few clouds, partly cloudy. 2 is misty, cloudy. 3 is light snow. 4 is heavy rain, etc., etc., etc. So basically, these are categorical data. We need to tell our, you know what? They're categorical data. Again, str bike raw, right? We got season, holiday, working day, and weather, right? They are not integers. No, no, no. They're categorical data. And we need R to know they're categorical data. All right, so how are we going to do this? Boom. All right, firstly, let's knock out holiday. Let's do holiday, then we'll do working day. Oh, do I have a typo? Oh, guys, I apologize. I have a typo here. So the first part is good here. We have holiday. The second part, I just have holiday repeated. This should be a working day. Well, that's fine. That's fine. You guys can make the change. I'll make the change in front of you guys, and you guys can make the change accordingly with me. So let's do holiday first. All right. Now notice I called the unique function again. And notice again, I'm going to call bike raw just the holiday column. I'm using the dollar way to do it. Remember, dollar, this is from list again. Dollar gives you, when you do it on a table, it gives you the selection of all the possible columns you can select to view. I want to check out holiday. I'm going to wrap that in a unique function. Again, function calling one function being called within another function, right? Go inside out. So there's only 2 unique values, 0 and 1. 0, it's 0, it's not a holiday. 1, it's a holiday, right? 0, it's a holiday. 1, it's not a holiday. And we can verify this again by using the table command, right? And as you can see, wow, there's a lot of holidays. 500 holidays, 6,879 not a holiday, all right? So from here, how do we go about doing what we did before? Well, we already used the factor function, so we just need to use the factor function not on a vector now, but now we need to use it on a column. Now we're going to use it on a column, and when we call in data tables, when we call a function on a column, we use the second region. We use the second region. All right, I'm sorry, up here, we use the second region. All right, and now we're going to do a bunch of things here. We're going to do bike raw, bracket, all the rows, okay? And which column am I converting or changing? Holiday, colon equals, done. Holiday, remember we have to do colon equals because within the data tables, for columns it's always colon equals. We're going to use the factor function, no problem. No problem, factor function, done. All right, so the first thing we want to do is, if you guys remember from up here, is we want to specify which column we are going to make into a factor. Obviously, we're calling holiday again because we basically want to make, we're converting this initial column holiday into a factor, right? Right now it's an integer, so we're taking these integer values and making it into a factor, right? In other words, a categorical data. Now, the initial levels are 0 and 1. I don't need to, because they're numbers, guys, I don't have to explicitly state this part. I don't have to say, hey, the levels are going to be 0 and 1. Basically, when I do this levels part, again, just as a refresher from the previous lines, I'm basically stating what are the possible values in this column. This column can only have, as we know from down here, 0 and 1 values. That's it. I don't have to explicitly state it because there's already just 0 and 1 values in there. So I'm good. But I'm going to do it anyway because I'm going to do it explicitly because so you know for other situations where you don't have numbers, where you have actually words, right, how to do it explicitly, right? So I have levels here. Again, I didn't need to explicitly do it, but I'm doing it again. I'm explicitly saying it's only zeros and ones. If I didn't put the level zeros and ones in, automatically it would just look at what's in holiday and say, okay, whatever's in there are the levels, the zeros and ones, done. All right, and the next step, the final step is what labels do I want? What labels do I want? So here I say no and yes, right? I know and yes. I'm going to get slightly more creative on my actual videos, and I will say, you can again, you can use no and yes as well, guys, right? In other words, not a holiday or yes, it is a holiday. But I'm going to go ahead and say not holiday. Yeah, fine, let's do that. So I will say not holiday and holiday. Or you can just do no and yes, guys, whatever. And that's basically how I fill out the three parameters within the factor function logically. The column stating what values should be in there. And again, I didn't need to do that because it would just look in there and see, okay, it's just going to be zeros and ones. And here I would have state not holiday and holiday. This needs to sync up. If I'm going to use levels, this needs to sync up with this. So 0 basically means not holiday, 1 needs holiday. So it goes in this order, this one first, this one second, this one first, this one second. So 0 corresponds with not holiday, the 1 corresponds with holiday. Now, if I didn't have levels, how would this would work? Well, because my underlying value are numbers, then it would automatically take the lowest number associated with whatever's here, take the higher number and associate it with what's there. That's basically what happens when you store these categorical data as numeric values, right? It'll, whatever labels you give it, it'll do it in order, lowest number to the highest number. All right. So I go ahead and I run this, right? And now close Bycraw and open it up again. If you look at holidays, look at what you see now. Now you don't see the actual values. You see my labels. Do you guys see that? You see my labels. Holiday, holiday, holiday. And now if I go back to str Bycraw again, right? If I look at holiday, look at that. It's no longer an integer, ladies and gentlemen, right? Compare it with working day, compare it with weather, right? Compare it with season. They're still integers. Now what does holiday say? It literally explicitly is telling us, hey, this is a factor with two levels, not holiday, and then it goes on, right? And the next one will be holiday, et cetera, et cetera. But bam, now R knows this column is a categorical column. Now R knows it, all right? So we knocked out one. Let's knock out the rest now, guys. All right. Scoot over so you have everything right there. The next one we want to do is working day. And again, I apologize, guys. I have a typo on my slides. I really should fix this. Here I just repeated holiday. I didn't make the change for work day, but let's go ahead and make the change for working day. All right. So just like before, I can do check out what I'm working with. Right. And as you can see, zeros are basically not a working day. And the ones are working days, right? Or ones are working days. Okay, good, fantastic. Now, if I want, I can be slightly lazy. Just copy my bad boy from here and make the changes I want. So this is going to be working day. This is going to be a working day. The levels, again, are 0 and 1. That is true. But now the labels will be something different. So here I will put for short, not working, right? And here I'll put working. Now, again, you can just use yes and no's like I do for my slides. I'm just trying to get a little more creative. This thing gets boring from time to time. You got to spice things up, little people. Do this again. And if you check out the table up here, if you rerun the table, you'll see that the change has been made. Let's see if the change is made. Yeah, I have to close it and then open it up again. Again, I can do view Bycraw. Another way to do it. And you'll see there's not working, working, right? And do str again. And you'll notice now holiday has been changed and working day both are now categorical data. All right. So from here, Now I need to do for seasons. And I need to do for weather. Now with seasons and weathers, the first two categorical data, guys, that we created, the first two factors, what kind of factors were they? Were they nominal or ordinal? They were nominal. See, you have a holiday or not a holiday, you have a working day or not a working day. There's no order there. There's no orders of magnitude. But now with seasons, all right, with seasons, well, technically, by the way, seasons shouldn't be, now you think about it, seasons themselves should not be ordinal data. Here I have that they're ordinal data. I think I kind of disagree with this, but we're going to go with this. We're going to go with this, right? We'll go with this. That it has ordinal data, spring, summer, fall, winter, whatever, right? I guess they're doing it by what the preferred weathers are, the preferred seasons are, which I have to disagree with. Ladies and gentlemen, fall is my favorite season. Let's just be honest. The crispness in the air, the change in colors in the leaves, pumpkin everywhere. You wear nice jackets. You can wear nice jackets, but you're not freezing out there. You know what I'm saying? The daytime's beautiful, nighttime is something about it, a taste in the air. You know what I mean? A little warmthness out there. I love the fall, and of course, the fall is also Halloween. God, I love Halloween. And obviously, Halloween kicks off what, ladies and gentlemen? Holiday season. Bam, one after another, one after another. Boom, 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 boom. All right, I love this time of the year. So, yeah, but anyway, for this particular example we're doing, just assume that seasons does have an order, right? Now, down here for weather, right? Nice day, somewhat not nice day, rainy, heavy rain, snow. Okay, that's ordinal. That is definitely ordinal. There's an order of magnitude there. The weather goes from nice to steadily bad, right? And so we'll put that out there. We'll put that out there. So let's go ahead and do the seasons one as well. I'm going to cheat and copy this. And boom. Oh, got to change my quotes. So here I'll put the actual seasons. And again, this is the benefit of defining your categorical data. Because look, when you're going through your data set and you see zeros, ones, threes, and fours, you're going to be like, oh, these are four numbers. Not that bad. What if you have, I've worked at one hedge fund, we had about, I would say 160 different numbers that identified different assets, different types of asset classes. You think I'm going to remember every number? Well, the ones that showed up a lot, like stock was like number 5, right? A public equity stock, a U.S. stock was like number 5. Okay, I'll remember that. You think I'm going to remember all those other numbers? This is why it comes in so handy, because you can assign labels. So even though your data is stored efficiently as numeric data in databases, when you're working with it, you can have the labels associated, correct labels associated with it, so you can do the analysis in a much more intuitive, user-friendly way. So here we go again. Again, I'm going to make the factors for season. Here, oh guys, I have another typo here. Look at that. I have holiday here. Typo. All right, fix that to season. Man, I have a lot of typos in these slides. This is supposed to be season, so let me change that to season. All right, that's correct now. I have levels 1. Notice, by the way, I'm explicitly stating the levels 1, 2, 3, and 4. So that 1 will be, let's go back here. 1 will be spring, 2 will be summer, 3 will be fall, and 4 will be winter. So I explicitly state the numbers, and then I have it in the order that it should be: spring, summer, fall, and winter. Now, there's an additional parameter that you have not seen before, and here it is, right? In lines 51 and 48, I didn't do this, but in line 53, I have to do this. I have to do comma, ordered equals T. Capital T means true. Notice it's a different color. It's a Boolean, right? It's a Boolean. That means true, okay? This now, when I run this, okay, bike raw now, if you will see, what am I doing? Just type it up here. If I run line 45 again. Now, guys, what you're going to see here is that holiday and working day factor with 2 levels. Nice. Season, notice this part right here, is an ordinal factor with 4 levels. And then it goes on to start explaining the labels it has. But now, instead of commas like down here, it has these less than symbols, basically showing the order, the level of the growth of magnitude from spring to summer, et cetera, right? This is a nominal categorical column. This is a ordinal categorical column. And here's our order of magnitude. They show some of it, not all of it, but they show some of it. All right, that's the difference between ordinal and nominal. And now, finally, ladies and gentlemen, we are on the last one, bike raw. Again, everything else I state again, 1, 2, 3, 4. So let me go ahead, clean this up. I apologize that it's on one big long line, but I just want to make it, I need the font large enough so you guys can see it. All right, but here I'll do it. So here it's going to be clear, partly cloudy. All right, now I say misty, cloudy. And here I say, I forgot a quote. And here I say light rain, light rain and snow, light rain or snow. And here there's going to be heavy rain or snow. The right proper quotes. And now it's going to be ordered equals true. I run this, run the str command, click on that box, and here you have it. Seasons is done right, working day, holiday is done right, weather, 4 levels, clear, partly cloudy, etc., etc., etc. Okay? Okay. All right, now let's take a look at our table, how it looks now. There you have it. Right now, the data is still in those integers. I cannot stress this enough. The data is still in those integers. But the way we're seeing it according to its labels. And we can always go back and change the labels. Right? But what's more important here, even though labels are great for us in terms of intuitive understanding what we're working with, what's great for us here is the fact that R now understands that we're dealing with proper categorical data. Because here's the rub, and even my BAP students, I didn't teach you guys this yet in BAP. We had bigger fish to fry, right? Because I want to get into the SK learn and machine learning. But when you're dealing with data sets for analysis purposes, you should never have a character column. I'm going to state that again. Very rarely should you have a character column. All right, I'm going to give you a little tip here. You should be dealing with numbers or categorical columns. You should never have characters here. All right? You shouldn't. If you have characters there, that means you have data in your table. That's fine. But that means that table is not ready for data analysis. That column is not being used for analysis. I'm going to talk about this a little bit more in the slides, right? But basically, I'm hinting at something here. There shouldn't be just a character column. It should be, if you have alphanumeric in your data, then it should be defined as some sort of categorical column, either numerical or ordinal, right? Or your numbers, you should have numbers or numbers that are there to do intervals and ratios and mathematics on, okay? All right, so that's just a little hint there when you're doing data analysis, when you're setting up your data for analysis purposes. All right, now, I just said you should not have characters. Look at the datetime column. Remember we talked before about R? Let me go back in my slides. Right here. It's kind of dark, I apologize. But you'll notice one of the data types is a date data type. Right? A date data type. in our databases, in our tables, we always want to specify when a date is a date. And that is a separate data type from anything else. Because a date is a point in time or some sort of period of our data. It basically is basically the core piece of the definition of time series. Time series are data that have some sort of time element with them. That's why date is a separate data type. All programming languages have a separate data type, including R, including pandas, right? So I believe my BAP students, you guys remember when we had to convert our date column into a date time, right? Same concept here. We have to do it here as well. All right. Now, but the difference here is, right? The difference here is in R, R doesn't have that. It doesn't have the to_datetime function in pandas built into pandas, where it automatically figured out what the date format was and converted it for us. R doesn't have that. We actually have to do a little more work in R than we had to do when we're converting our when we're converting any kind of date column that's in a different type. Usually it's in some sort of alphanumeric text type, right? In our case, it's it's alphanumeric. Usually that's the case. We have to do a little more work converting this from a character into an actual date time object, or a data type. All right. So firstly, let's view how our date actually looks right now in our table. All right. Oops. Yeah. There we go. All right. There we go. All right, this thing's going a little crazy here. There we go. All right. All right. That's our table. All right, so I want to just view the actual date column. So I want all the rows but the date column. You guys know how to do this now from lab 1. So all the rows and just date time column, right? Comes back as a vector. That's nice, right? Or for my slides, I can give it back as a data table. I can output it as a data table for me to view. Boom. All right. So notice the format here, guys. Month, day, year, space, and then the time, right? Then the time. Now, we need to convert these characters. Remember, because it's a string right now. This in from the point of view of R, this could be a name of a city, a state, individual, piece of food, clothing. R has no idea these are dates. We have to tell R that these are dates by converting it into an actual date column. All right. So here I'm going to use the as.date function. Here I'm going to use the as.date function to create the dates. Now, how does the as.date function work? I'm going to give you guys an example. Firstly, what I'm going to do is I'm going to create a vector of actual dates. I'm going to create a vector of actual dates, right? So here I have, copy this, right? Now I'm going to do 2 of these. I'm going to do this one to show you guys the difference. Now notice I'm using a function called as.date. As.date literally as.date literally we have the C vector here, the C function. So we're creating a vector of dates. Now, when we create our own like date within R, we have to use an as.date function because we have to pass the date in quotes, all right? And then we have to pass it into the as.date function. Outside of that, if we don't do that, R is going to, if we don't use the as.date function, R is just going to consider these to be characters again, right? We have to use the as.date function. Now, notice the format that I passed the dates into, the as.date function. YYY, year, dash, month, dash, date, both in 2 digits. 2-digit month, 2-digit year. So I run this, and you'll get something like this. These are dates now. These are dates, right? And that's the format of dates in R. The format of dates in the data table is the same as in Pandas, actually. YYY, year, dash, month in 2 digits, dash, days in 2 digits. All right? Now, let's say I create this price column right here. All right, just to show you. Let's compare it side by side. Right? And if I do str samp dt, you'll notice this table, this temporary table I have, this is the date format, this is a number. All right, that's what we want. We want to see the date format. That's what we want. All right. Now, for our purposes, we're going to use the as.date again, right? When we're converting our date time column into a date time. So we're going to pass in the date time column that we're going to convert into a date. And obviously it's the date time column we're overriding. But notice now, from the first example, I have an additional parameter here. Why is that? You see, when I used it up here, I had the dates explicitly in the right format. Year, dash, dash, dd, dash, month, dash, day. But if you go to my R right here, right? Again, let me just execute line 56 again. You will see that you have your date times. Are they in that format? This is the standard format of dates in R. Is it in that format? No, your characters are not in that format. If we try to run this with just as.date and nothing else, R will be confused because in the first 4 values, it's looking for the year. Then it's looking for a dash, and then it's going to be looking for 2 more digits to tell us the month, right? This date is not written in that format. So we need to tell R explicitly what format it's written in. And now enter the syntax for formats of dates in R. Okay? It's actually quite similar to the formats of dates in Excel and Python as well. So again, you have to do, let's write this out. All the rows, I want the column date time to be overwritten, and I want it to be converted into a date, right? And I want to use the original column to do it. And now I have the extra work of specifying the actual the actual format that this column's in. All right. So here's how we do the format. First of all, quotes. I have the quotes there. Now I need to look at how it is, the dates here. We have the month slash the day slash the year in a 4-digit year. When we're dealing with the as.date function, the syntax to specify month, day in a 4-digit year, right? I'm sorry, to specify the month as 2 digits, the day as 2 digits, and the year as 4 digits is lowercase m, lowercase d, and uppercase y. All right? But you also have to put in, because these are codes being used according to, and this is a syntax for as.date, right? Before you use any of those letter symbols, you have to put the percent before it. So %m pretty much is telling as.date, the as.date function, okay, cool. The first possibly 2 digits are the month, all right? Then there will be a slash, That's why I put a slash there. Then there'll be a slash, and then the next possible 2 digits are going to be the day. The next 2 possible characters you see will be actually the month after the slash. And then there'll be another slash, and then we will have the year in 4 digits. 2001, you can see here, right? And then after the year, there's a space. And then after that, there is the hour and then the minutes. That's what we have here, the hour and the minutes. The minutes are all 0. And to specify hour, it's going to be percent %H, and then there's a colon, because there's a colon right there, guys. And then there's the minutes. And that's percent. That's percent capital M. Everybody see this? All right? Bam. We are explicitly telling the asDate function what the format of the date is in our column. So basically we're telling as.date, look, check it out. The first 2 characters you got, that's the month in a 2-digit format. The next after the 2 slashes, after the first slash is going to be the day in 2 digits. And then after that slash is going to be the 4 numbers will be a year. There's a space, and then we got the hour going on, all caps, a capital H, sorry. And then there's a colon, and then we got the minutes, and that's capital N. So these letters right here, uppercase, lowercase, again, this is syntax for the as.date function. These are parameters. These are predefined in the as.date function. That's how we use as.date. So to go here, I run this, and if I run str on bike raw again, what do we see? The date time. It's correct. It's correct now. All right? It's now in a proper date time manner. If I open up my bike raw table, you will now see that the format has changed of date time. Now it's in the correct R format. See that? It's in the correct R format. It's now an actual date column, right? And by the way, that's probably the second most mistake you'll see. After nulls, you'll see the mistake of your dates, your date column or any kind of dates are stored as strings as opposed to stored as data types. Very important for analysis, even more important for any kind of time series analysis. Alrighty, so that we knocked out. Now, if you'll notice, when I'm looking at my dates here, guys, right, what's missing? It's the dates, but the time's not there. Why does the as.date function do that? It does it for the sake of memory, for the sake of efficiency, right? A lot of times you might not need the time. Drop it. It just takes up way too much space. But let's say explicitly you need to use it. Let's say explicitly you need to use it, right? Enter this other function called strp time. So before we used as.date, we can use this as well for strip.time. Now, oh shoot, you know what? I just realized that I got rid of the original data. So let me run it back. So let me run this back. It's no problem. I'll just run my line 4 again. So I overwrote this. Let me make a couple changes here. This is numerics. I'll do my factors. This, holiday, working day, season, weather. And now what I'll do is, before I do date time, I'll do date time again. I'll just add another column. I'll just add another column before then, just to show you guys this example. So I'll use strip time, strp. There you go. And I'll call this something else. I'll call it period, just so you guys can compare it side by side. All right. And you'll see a whole bunch of errors warnings came. That's fine. And now I'll run this one just so we have date time as a proper date. Click on bike raw. So date time is fine, but you'll notice I added an extra column over here. See that? And that's because I used that function, and it has the same effect as before, but this time it's stored as a date time, but now it has the time associated with it. Okay? You might need that, right? You might need that. So I just wanted you to share. I just wanted you guys to have that function there. I mean, generally we try avoiding that because of, again, large how much memory it's needed to store that. But look, hey, I've at hedge funds I've worked on analysis where we have um, we have prices that are minute by minute, right? In some cases, I at Citigroup, I remember we were working on a project. There was a project we were all working on that involved tick by tick. Forget seconds. So every second there was a bunch of prices coming, right? At the hedge fund level, it was more like, every within the hour, there's one or two prices coming or something along those lines, or something's happening, some sort of data point. So look, I mean, there's times we have to use this, right? Without a doubt. So there you go. So at this point, guys, if you look at here, we have our daytime, we have our seasons. This is now, daytime is either going to be a date or this what we call this POSIXCT object is pretty much a daytime with time. Either or, we have our factors here, ordinals, numbers, integers. We took care of all our mistakes, our errors, and we have no more characters save one, sources. Sources. That's the last piece of the puzzles. All right? Now, let's talk about this. What I was talking about, I was applying this before about characters, why you shouldn't have characters in your table, right? It should be, if you have alphanumerics in your table, then it should be some sort of category, a categorical data, nominal or an ordinal one, right? If you check the source column, right, it's still a character data type. R cannot group character items to summarize them in analysis. I'll say that again. R, if a column is of type character, R can't group them together for the purpose of analysis, right? It should not be there. Look, you can have tables with characters in them. That's fine. But those tables, but you should always take a subset of that table for analysis purposes. When you have a table you're doing analysis on in R, you should never have a character column. It can't be summarized. It can't be sliced or diced according to that column. You'll see what I'm talking about when we start doing some visual analytics in chapter 3 or lab 3. This implies that maybe our sources column should be a categorical data too. But before we can do that, right, we need to analyze the data within that column. The other ones were easy to knock out. In this case, this sources column is more indicative of the type of character or alphanumeric columns you will deal with at work or in your projects, right? So to be specific, we need to look at what is sources all about. So the sources column is basically all the advertising sources for the table, like where the advertising sources came from, right? So we have to ask ourselves a question. How many I have a typo here, it says kids. How many unique kinds of advertising sources, firstly, are there in sources, all right? Basically, how much variation in the data do we have? Second, how many categories would we like to have in our analysis data set? Remember, you can have a table with characters in it, that's fine. But if you're doing analysis on a table, you always must take a subset of that table that follows the rules we just talked about. So it's ready to go for analysis. And the question is, in our analysis data set, which this is what we're making right here. How many categories would we like to have? Okay. So firstly, let's take a look at all the unique values in sources. Bam. All right. So it looks like there are 1, 2, 3, 13, 14 different values. 14 different values. Okay. That's not bad. 14 different values. All right. Okay. Now, Here's some observation. Here, it's a little clearer to see here. Before we even attempt to answer the question of how many categories we would like to have in our data set, let's look at what we have, our results. We have 2 Twitter values. Look, we have a Twitter value here, meaning that we had advertising coming from Twitter. And we have Twitter here. Why do we have 2 ones? Look at the quotes. This first one has a quote here and immediately right after it. Look at the second one. Quote here, and then there's some space and then another quote. This particular Twitter value has space after it, white space after it. We get this all the time. You get this all the time. Second observation, look at the ad campaigns. So we have an ad campaign here, capital A, lowercase d. We have an ad campaign here, all caps AD. All right. And we got another ad campaign here, lowercase a and d. What's going on here, guys? What's going on here, right? Again, they're the same thing, just written differently. And then, of course, we have the nulls that we need to address in one way or another, right? The nulls we need to address one way or another. Okay? So firstly, before we even think about anything else, let's fix these obvious mistakes, all right? Let's fix these obvious mistakes. Now, the 2 Twitter values, the multiple ad campaigns, and NAs. Now, let's first address the fact that we have our ad campaigns are of different types. An easy way to deal with this, guys, just make everything lowercase. Just make everything lowercase. And in R, we have a neat little function called toLower that makes alphanumerics all lowercase. And obviously, we have another function toUpper to make everything uppercase. All right. So I'm going to go ahead. I'm going to address the easy. Remember, we always take the low-hanging fruit first, to do the easy stuff first, right? Bam. All right, now I'm going to go ahead, run this again. And now notice I went from 14 unique values to 12. Why? Because what happened was the 3 ad campaigns now coalesced into this one variable. Perfect. All right, so I went from 14 to now 12. Excellent. All right. The next one we want to address is the extra white space we have with Twitter right here. Here's Twitter, and there's the other Twitter with the extra white space. So again, R has a really cool function. And guys, my BAP students, Pandas has all these functions too in the str library. That's what I mean. The str library, really powerful. The str package within Pandas. So here we have a function called trim WS, trim white space. And the cool thing about this trim white space function, there's a bunch of them. The cool one about this one, it trims white space before and after every word. Before and after every word. So we just have it after, but you know what? Just in case, let's throw it on for before too. I run this now. All right. Now I go to unique. Excellent. So now I went from 12 to 11 because now Twitter, the two unique Twitter values coalesced into one. All right, fantastic. All right, 11 values left. Now we have 11 values left. Is that better? All right, is that better? Now before we get into there, we have the NA, the null. In this case, remember I said that depending on the project or analysis you're doing, the NA, you have to provide context for the NA. In this case, it's just unknown, right? If there's a null in the sources, that means we have no idea where it came from. So you can write other or unknown. In this case, we're just going to knock out the nulls and say, look, it was unknown. We have no idea where those values came from, right? And we don't leave it as null. For analysis purposes, null is there to be annoying to you so that you, both in Pandas and R, so that you address it. We have to address it. And this is how we address it. We just basically say, look, we don't know. All right? Unknown or other. Done. All right? And now we addressed all the obvious problems with the data when we go through the unique values. Sweet. Okay? Now, again, like I said, we're down to 11 values. Is that better? Well, class, is it? Enter Miller's Law. All right, I have a link about Miller's Law right here. If you want to go here, this link and read about this extensively. It's a very, very interesting phenomenon. George Miller, a Princeton professor and psychologist, stated that the number of objects an average person can hold in working memory, in our memory, is about 7, also known as the magical number 7 plus or minus 2. So basically, this guy in Princeton, all right, comes out with this crazy idea saying that, look, in our minds, an average human being can work with 7, pretty much 7 different things in their mind with the range of, we would say, 5 to 9 items. So plus or minus 2. So basically between 5 to 9 items in my mind. 5 to 9 things any given moment you can analyze. All right. Now this is a crackpot. I mean, outside of if this guy wasn't in Princeton, he would be considered a crackpot. But and again, please click on the go to that link and please check it out. This is very fascinating. But we somewhat know this to be true. You guys ever heard of the concept of curse of optionality? The term curse of optionality, right? This is when you are basically given so much choices, or so much choices that it's impossible for you to make a decision, even for something you want. Like, for example, you guys ever walk into a clothing store and there's just so many different types of clothes? You're like, nah, or let's say you want to buy a shirt. You walk in and you're like, so many different types of shirts, and you're like, yeah, I can't do this, right? Ladies, you probably never have that problem. I'm stereotyping here, but fellas, right? Sometimes you're like, nah, it's too much. Or you walk into an electric store, you see all these TVs, and you're like, yeah, I don't know, right? Or actually, the perfect example is Amazon. You go on Amazon, you're trying to find a specific thing, and there's so many different models and variations. You're like, I have no idea, I'm not sure. And then you fall to the ratings and try to figure it out. This is the curse of optionality, right? This stuff is real, right? This stuff is real. In fact, have you guys ever heard about the trick when you're selling technology, when you're selling tech? So when you're selling tech, you'll notice that most stores tend to have roughly around 3 options. They have a cheap bare bone option. Then for more money, they have a better version. And then for incredibly more money, they have the best option, which is not that much better than the second version, than the middle option. Any idea which one gets bought most? Which one most people buy? They buy the middle one because the middle one is more expensive, right, than the first one, sure, but it has so much more features. But the third option, it has even more features than the second one, but not that much more, but it's so much more expensive. You see, they're adding they're doing another trick. They're called anchoring, right? If you just had the cheap version and the medium version, you know what one everyone would buy? The cheap version, because the medium version is more money. But once you have this more expensive one, right? That expensive price is now anchored in your mind. And now that medium choice does not look so bad. It doesn't look that expensive. In fact, it looks like a great deal because it has almost as many features as the third one, but it's nowhere near as much. This kind of is adjacent to this whole theory, right? About what you can work with your mind and how your mind works. In our example or analysis, like I keep stressing this in pandas and data tables, we never get all the results back in our data tables. They always give a summary of the top 5 and the bottom 5. Same thing with pandas when we're working with in Spider. This is because both applications are like, yeah, what are you going to do with 1,000 rows, bud? You're not going to be able to look at 1,000 rows and be like, oh, okay, cool. Yeah, I know what to do. I know what I want to do, right? It doesn't work that way, right? This is because Miller's law is in effect. Miller's law is in effect. That's basically what it's all about. All right? So, given that, from a business point of view, after discussing it with advertisers, you might come to the realization that, it's not important to know which search engine the user used, just that they came from the web, right? Well, I mean, if it matters if you're paying for Google AdWords or something like that, but outside of that, if you're advertising and people just came from the web, that's fine. That in itself is fine. Therefore, right, what we want to do is everything that came from the web, or I'm sorry, from a search engine, we want to change that to basically to say the word web or search engine, right? In this case, I just say web, all right? So where do we have the search engines? Google.fi. I think that's Finland. Finland's Google. That's cool. England's Google right here. This is Yahoo. This is the normal Google, right? And Bing. Whoever uses Bing, right? So all these, we can pretty much break them down into be like, I don't need to know explicitly which search engine was used to find my product. I just want to know that, look, it came from like a search engine or the web. That's all I care about, right? And so now what we want to do is we want to break down all those search engines into just one term, the web. You guys know we've done this before. We're going to use the grep command to do this again. And to do this grep command, we're going to, this allows me to show you guys more features of the grep command, right? And to be more explicit in how we did it. Before I mentioned to you guys using the brackets, right? Using the brackets. What the brackets does is the brackets basically means, right? If I just had the single A there or A dash Z, then what that outside the brackets, what that would mean is show me one instance of. But because I have these in brackets, this basically says, all right, show me any of the letters from A to Z. And notice I have a star there afterwards. So what does a star mean? Unlimited amount of combinations. So basically, show me now any word, letter or word, that has the letters, lowercase letters from A to Z. So basically any word in the dictionary, right? And same thing with this part right here. Any word in the dictionary. Done. All right? But notice in the quotes, I'm wrapping this up. So now I have this star here after the brackets. So that's what the star basically means. Show me any length combination of these letters. So basically any possible theoretical word. But notice now I have www dot first. Okay? And then I have this part, dot, then I have this part. All right? So basically, we're saying, hey, grab any word that starts with www dot, then has any word basically after it, then another dot, and then any word after that. And again, it's any word because bracket A-Z bracket basically means any of the letters from A to Z, any of the letters from A to Z. But once you place that star after it, that's basically saying as many times from 1 to infinity amount of letters. So you can have literally A, Z, B, AB, whatever. It just keeps saying that, hey, you have like more than one letters. More than one letters from A to Z. It's not looking for a specific letter. It's looking for any combination of letters with lowercases a of Z, right? And the same thing after the last part, dot, after the last dot. So basically what's happening is any combination with www dot afterwards, it's grabbing, right? Google, that's 6 letters from A to Z, that fits. 4 letters from A to Z, that fits. 2 letters from A to Z, that fits. 3 letters from A to Z, that fits. So it's going to grab basically everything with this format, with starting with a www dot, right? So, and then this part's going to filter it. So we'll do a step by step again, guys. I'll do a step by step for you guys again. So let me take this part out right now. Let's first filter the rows. Done. All right. And now all the rows are being filtered that I want. And you'll look here in sources, right? See that? Look at that. It's basically everything with www dot, and then any amount of letters from A to Z, dot, any amount of letters from dot A to Z. All right? Had I did, look, A dash C, then it would be www dot any amount of letters from A to C, dot any letters from A to C. You guys get it? That's how we play with this grep commands. All right, now, Here, I specify just the sources. And now I just get one column. See that? All these values. It's all the www dot values in all their combination. And now I'm going to overwrite this, guys, to be all these values will now finally be web. Run this, and now I do unique again. Looky, looky, 5, 6, 7. Perfect. Right? Again, anything between 5 to 9, usually we like to narrow it down to. And think about it. From anywhere you work, analysis purposes, right? You always want to narrow things from 5 to 9. You give your management a thing with 20 options, they're going to be looking at you. They'll look at it and they'll smile. And by the way, in corporate America, there's tons of reports that are, I think like 80% of reports that are generated, nobody reads. Nobody reads, but they just have it there just for in case something hits the fan. They're like, oh yeah, we have this report, right? And the reality is most people don't read these reports is because it doesn't, they as a human being, they can't get any kind of analysis out of it. They can't make any decision off of it. I mean, they can't even understand what's happening off these reports, right? Let alone make a decision off of it. Miller's law. Miller's law. So we hit it on the head. We got this down to 7 different values. So now we have this, we have a perfect amount of levels at this point. And so at this point, we have 7 and we are ready to rock. Now here, I just left it as this, but you could take it one step further and now convert this column, the sources column, into a categorical column as well, right? And obviously it will be a nominal one. It's now a nominal. It's now a nominal column. And you can go ahead and do the command. I'll leave that for you guys to go ahead and do. Convert it into a categorical column. But at this point, we're pretty much done. We took that simple data set and we cleaned it up. And now, ladies and gentlemen, we're ready to do analysis. All right? We're ready to do some sort of analysis. Next step. All right, so this ends our video for Lab 2 or Lecture 2. And I'll see you guys at the next Q&A session or at the next video. All right, have a good day, guys. Bye-bye.